So we've seen that sets are a really nice data structure if you want to compare two groups of items but don't really care about their order. And this actually turns out to be handy in a number of places. Imagine we wanted to offer a service where people could ask for the flight distance between two cities. So we might want to look at the distance between, say, Los Angeles and New York. It's about 2,498 miles, and return that value to them. If you start thinking about this, it actually fits in a dictionary fairly nicely. You'd like to have a city pair that is the key, and then the value would be actually the mileage between those two cities. And it doesn't really matter if somebody asks you, I want the distance from Los Angeles to New York or New York to Los Angeles, it should return the same value. So we can think about actually building a dictionary. Let's look at this. So I'm going to create a flight distance dictionary here. And it's just going to be, remember we used two squigglies, and that's going to be an empty dictionary. And then I'm going to have a city pair, and I'll just name that pair here. And this city pair is going to be Los Angeles to New York. And now I can enter in here the flight distance between this city pair is going to be equal to 2,498 miles. So we'll enter that in, and immediately we get a complaint. And the offending party here is pair. It says there's a type error. We have an unhashable type set that's used to try to be the key in our flight distance dictionary. And in fact, that doesn't work. You remember sets, we can change them. We can add values to them or delete values from them. And immutable objects can't be used as the key in a set. But there's a solution here, and that is a special kind of set called a frozen set. So I'll just say my pair is equal to frozen set pair. And so I've converted my pair into what's called a frozen set. And if we go look at this, you'll notice that, in fact, a pair, when it's a frozen set, has a lot of the same operations like union and difference and that sort of thing that a normal set does, but it's actually missing some of the features. Specifically, it doesn't have methods for adding or deleting. So you can't change a frozen set once it's been created. So now I can go back up with my same line up here, frozen distance pair, and we can enter that in. And let's do a couple of others. Let's think about a couple of other cities we might want to have. Maybe we have, and I'm just going to create these straight away here. I want a frozen set that included Austin to Los Angeles. And then we'll set the distance for that. And Austin to Los Angeles is about 1,233 miles. And we can do the same thing with Austin to New York. And it's a little further to go to the East Coast here. So it's 515 miles, or 1,515 miles. And now if I look at my flight distance dictionary here, we have three sets of keys and values. We have Austin to New York for 1,515 miles. LA was 1,233, and to LA to New York was 2,498. Now if I come in and want to query this, I can say flight distance, and I can ask it, listen, I want to pass in a frozen set to look up the value Austin to Los Angeles. And that gives me back my 1,233. And if I change the order of these, then I get the exact same value. So we're using this frozen set as a key into a dictionary so that it can be used as an immutable type, and it gives us this nice feature of being able to look up a key that you don't care about the order of the objects in it.